All right, welcome everyone to lecture 13 of 1413. This is my last lecture on social preferences. I hope all of you are doing fine remotely. Hang in there, I know this is a very difficult time. This lecture is a bit of a more uplifting lecture than the previous ones. Well, the previous ones have looked at social preferences, how we can measure social preferences, and how can we perhaps isolate pure altruism. Do people really want others to be better for their own sake, even if nobody knows about it, either others or whether there's no feedback? We sort of found out that it seems like what looks a lot like altruism, people are nice to each other, is not pure altruism in the sense that they really want others to do well. Instead, they want to either look good in front of others, or they're worried about reciprocity or sort of any other negative feedback from others. Or it might be they might want to protect their self-image. They want to look good in front of themselves, and they try to figure out ways to deceive themselves that they're nice. And if given the opportunity to not be nice, people actually seem to be not as nice as one might think from pure dictator games or ultimatum games that we observe. This lecture is a bit more uplifting in the sense that it talks about field evidence on social preferences. And in particular, we're going to ask the question about how can policies increase pro-sociality in certain ways. We're going to talk about three broad sets of studies. First, we're going to talk about social preferences at the workplace. And we're going to talk about the impact of relative pay on productivity. We talked about this last time at the end of the lecture a little bit, but I'm going to just restart from scratch to sort of explain that a little bit better. Then we're going to talk about the morale effects of pay inequality. What happens to worker inequality when people are paid unequally, and is that a good idea? There's also a very nice paper on ethnic divisions and production in firms. We're going to talk about this a little bit in recitation. Number two, we're going to talk about whether policies can induce pro-sociality. In particular, I'm going to focus on mixing. This is sort of called the contact hypothesis. When you mix people from different backgrounds, do they become nicer to each other in various ways? Discuss a very nice paper by Gautam Rao on mixing rich and poor children in school. We're going to talk very briefly about mixing cricket players in India to reduce tensions across castes, or make people from different castes perhaps more pro-social to each other. I'm going to also briefly mention a study on mixing roommates in college by Corno et al. Finally, we're going to talk about whether people perhaps underestimate the benefits of pro-sociality. In particular, I'm going to show you a study on people undervaluing gratitude. So when people write letters of gratitude, do they understand how others might react? And is there perhaps some evidence that people are not pro-social enough because they misunderstand the effects that might have on others? Okay. So let me start with social preferences at the workplace. So Bandiera et al. Is a very nice study that looks at the impact of relative pay on productivity. This is field evidence from a fruit farm in the UK. It's literally field evidence because it's from fruit picking farms from fruit fields. The study looks at two types of payment schemes. These are piece rates. Workers are paid per unit of output. And the second scheme is relative pay. Workers are paid relative to others. We might sort of think that relative pay is a good way to incentivize workers because, you want to do better than your neighbor, and there's sort of a competition of who does best. And in principle, it could be that that really, if you only care about yourself, that really gets people to work very hard. Now, what Bandiera and I look at is how does the introduction of relative pay affect workers' effort and output? Now, one thing they notice is that while relative incentives might be good because you might sort of induce people to want to be better than their neighbors or their coworkers, there's also a negative externality of relative pay. That is the idea that increasing your own pay comes at the cost of others' pay. That is to say, if there's relative pay and I work really hard, I'm paid how I do relative to my friends or others that I'm working with. Well, if I'm working really hard and do better than my friends, I'm going to be paid more. But at the same time, my friends, for any effort that I put in, my friends are going to be paid less. And so workers sort of anticipating these impacts on others might reduce their effort if they care about others, right? If I'm really worried about, like, if there's relative pay and I work really hard, my friends are going to look bad, they're going to be relatively unproductive, and I worry that they might not be paid enough, then I might reduce my effort, and sort of everybody might do that, and then the introduction of relative pay or the relative pay schemes might actually not be particularly effective or effective way of incentivizing and motivating workers. So there's sort of this tension that relative pay in principle could work quite well, but if people really care a lot about others, then it might not work at all. It might actually backfire in some ways. Notice that it could be either that people care about others for their own sake, in the sense that, like, you might care about them because you want them to have high earnings, or you might care about others' earnings not because you actually care about the outcomes per se, but rather because you're worried about negative repercussions, right? If these are your friends and you worked really hard, well, at nights your friends might really not be happy, and there might be sort of retribution against you socially or in some other ways if you work too hard, if you cause them their earnings to go down. Okay, so now what does this paper do? It looks at how does switching to piece rates affect people's productivity. So the study has personnel data from a fruit farm in the UK. They measure productivity as a function of their compensation scheme. This is a quasi-field experiment. The timeline is as follows. For the first 8 weeks of the 2002 picking season, fruit pickers were compensated on a relative performance scheme. So the per fruit piece rate is decreasing in average productivity, right? So, like, if everybody works really hard and I don't, if I'm relatively bad compared to others, I get less than others. The incentive to keep, this is sort of an incentive to keep, as I discussed, to keep the productivity low if you care about others. And then in the next 8 weeks, compensation was switched to a flat piece rate per fruit. So that's essentially just like you're paid by how much you produce, how many kilograms of fruit you collect, and the payment is entirely disjoint or independent of what other people do. That's like a classic piece rate payment. So the externalities are entirely shut down. If I work really hard, I'm going to be paid. There's no effect whatsoever on my fellow workers. The switch was announced on the day the change took place, so it came as a surprise to workers. So we should not be worried about sort of pre-trends or productivity going up over time anyway. Now, what the paper finds is a dramatic increase in productivity with the introduction of piece rates. That is to say, what you see here on the figure is the average worker productivity for 2 of the fields. So this is essentially like broad, big fields where people work on. I'm showing you sort of the data for 2 of those fields, for which essentially on most days there was actually production. Workers were picking fruit. What you see on the left side of the graph is when people were working under relative pay. There you see essentially relative flat productivity. People had about like 5 kilograms, picked about 5 kilograms per hour. There doesn't seem to be any trend upwards over time. So before the new policy was introduced, essentially workers were producing or picking their fruit at a relatively constant rate over time, about 5 kilograms per hour. There was no trends, as I said. Now then, you see so the vertical line in the middle. This is when piece rates were in fact introduced. So there was no relative pay anymore, and now people were paid by piece rate, and that increased productivity by over 50%. So workers became a lot more productive after that. That's true for both of those fields. It is not the case that the average payment per unit of output per kilogram of what people were paid was going up. So you might sort of say, well, if the piece rate was actually higher under the piece rate payments on the right side of the screen, well, maybe then, of the graph, then maybe workers would just be more productive. But in fact, if you look at sort of the piece rate over time, if anything, the piece rates actually went down over time what the company was paying. So that is to say, the introduction of those piece rates, the productivity effect is not explained by workers being paid more per unit of output. Instead, it seems to be really coming from the different incentives workers have when it comes to how their productivity affects their fellow workers on the field. Now, you might have sort of like two potential explanations here for this evidence. One is social preferences. So you might work less to help others under relative incentives, right? And you might even less when your friends benefit. So if you have many friends on a certain field that work with you, well, then you might be particularly inclined to not work very hard because you will care a lot more for them. And this is sort of exactly what they find in this paper. These effects are stronger when there are more friends on the field for a particular worker. Second, however, it's also like a repeated game. That is to say, there's sort of a low effort equilibrium where essentially if there's relative pay, we can just all agree, everybody on the field might sort of agree that not working particularly hard is a good idea because we are essentially paid relatively anyway. So if everybody doubles their effort, nothing is going to pay. There's nothing that's going to happen to workers' compensation. So you might as well just decide. Everybody could just decide work half as hard, and we're going to be paid the same. And as long as we sort of can sustain that equilibrium, that's a good idea. Of course, in any given period, any given worker might have the incentives to deviate from this equilibrium because on any given day, if you work really hard, you're going to be paid a lot more for that day. And so how might we be able to disentangle that? Well, what Bandiera et al. Have is they have also some variation in the types of fruits that were collected. What do I mean by that? Well, if you think about what you need to be able to disentangle these, what you might want to have is like differences in the observability of effort. Right? So if I can see what my coworker does, I can like punish them very effectively. I can just know like whenever Frank is working really hard, my coworkers might want to punish me, and then it's very hard for me to work really hard because I'm getting in trouble at nights after work with my coworkers, or the next day everybody might also work really hard, and I kind of don't want that. On the other hand, if I can hide how hard I'm working, well then, I might secretly work really hard and my coworkers might not even find out. So then, if that's the case, in the repeated game equilibrium might just not be enforceable, as in like, I might just tell my friends, oh, I wasn't really working hard, but in fact I was, and like they have no way of finding out because I was sort of unobservable. If instead I really care about them, if I'm really interested in their well-being overall, in their payment, it doesn't matter whether my effort is observable. Regardless of how observable my effort is, I will not work really very hard because not working hard makes them better off. So if we just had some differences in observability in effort, how hard people work, we could just disentangle these two explanations. So Bandiera and I'll have this very nice variation. They have two fruits. They have fruit type 1, which are strawberries, and they have fruit of type 2, which are raspberries. If you ever picked strawberries, you would know that strawberries is very easy. These are like essentially very flat and low fruit that when somebody picks strawberries, it's very easy to see how fast somebody works, how much anybody picks, and so on, because you can just see across the entire field. You can see essentially what all of your coworkers are doing. In contrast, if you look at strawberries, if you look at raspberries, these are bushes, so you can essentially literally hide behind the bushes and work really hard or pick really hard and fast without others noticing. So essentially, productivity is at least more unobserved than for strawberries. Now, what Bandiera et al. Then find, in fact, is no impact of the piece rate on fruits of type 2, which is raspberries. So that sort of suggests there's no evidence of pure altruism, and the effects perhaps could be driven by reciprocity. This is kind of consistent with what we had found before. When you remember the dictator or ultimatum games that we showed you, it looked a lot like people are altruistic, they care about others, but when you look at their actual motives, when you dig a little deeper, we find out that in fact this is driven by reciprocity or by worries about repeated game effects or worries about essentially just retribution, either on the field that other people will work also really hard if I will work really hard right now, or socially after work my coworkers might be really mean to me, they might even beat me up, or they might not be my friends anymore. And this is here sort of regression tables that show you this. The first column you see fruit type 2. Again, these are the raspberries. This is when things are unobserved. There's no effect of introducing the piece rate. In contrast, if you look at column 2, this is fruit type 1. These are strawberries, and there's large productivity effects of strawberries there. So these results, again, highlight the importance of setting the incentives carefully. Small details matter, and you really want to be very careful in how you set relative incentives that in principle seem like a good idea because they sort of provide steep incentives to workers, but in practice might actually not work particularly well. So the second paper we're going to look at is Breza et al. These are the morale effects of pay inequality. This is a very nice randomized field experiment in rural India with low-skill manufacturing workers. The question the authors ask is, do workers care about relative pay? And perhaps why do we see so little variation in pay across settings? So what we often see in many companies in India, but also in other places, also in certain villages in India, what we see is wages tend to be very compressed. So workers essentially earn the exact same wage regardless of their underlying productivity, experience, and so on. Good and bad workers tend to earn exactly the same amount of money per day or per hour and the like. Economists think that's inefficient because, if you want to hire somebody who's really, really productive, you might want to pay them more. If you want to hire somebody who's not that productive, you might want to pay them less. You might actually want to pay them less than the prevailing wage, but you might not be able to do so because the norm is that you have to pay them the prevailing wage, and then you might end up not hiring that person, and that person might end up being unemployed, even though you would be very happy to pay him at a lower wage. This is really a really relevant question. There's the second question the authors ask is, what is the notion of the underlying notion of fairness? What is kind of fair and what's not fair? As in, if there is wage dispersion across workers within teams or within a certain firm, are there some circumstances under which that's okay to do? Are there some good justification that workers are okay with? Or in contrast, is it just always bad to do so? So can we sort of find some situation under which it's justified for workers or not? Or is it just we cannot have pay inequality under any circumstances in those kinds of firms? This is potentially quite relevant for many features of the labor market. It might explain wage compression. That's what I was saying, wages tend to be fairly compressed, even if productivity is fairly dispersed across workers. There tends to be lots of wage rigidity. Wages tend to not move very much. It seems to be employers have trouble adjusting wages, or they are reluctant to adjust people's wages much, in particular when it comes to downward rigidity. We talked about this a little bit already when we talked about reference dependence. We can also think that can help us think about sorting of workers into firms and inequality. We can think about firm boundaries in a sense to say should there be really large firms or a number of small firms? If you think the relative comparison is across workers within firms, that would sort of say, well, we should probably have a lot of small firms, and then each of these small firms could have different wages, as opposed to one large firm where essentially everybody has to be paid more or less the same. And we might think that's inefficient because there's returns to scale of having a large firm. Think about also, this is also relevant for some HR policies in terms of how do you pay workers, how do you set wages, and so on. So as motivation in a study, the authors ask people the following questions. The question is the following. This is rural India in Rissa, a relatively poor area with lots of small-scale manufacturing. The question is, 3 people from a village get hired to work on a construction site together. The prevailing wage is 250 rupees in the village. That's kind of the standard wage in the village. Each village tends to have like a prevailing wage, which is like how much people are paid usually. The contractor pays them 250 rupees per day. How well will they work together? And what you see is what respondents tend to say is like 80% of respondents say people work very well together, 20% say as well as usual, and 0% say there will be conflict. So that's kind of like, seems like paying everybody the same is a socially acceptable thing to do. Everybody seems happy with that. In contrast, if you ask the following, which is the contractor pays them different wages. If the contractor pays 250 per day, 270 per day, and 290 per day, how well will they work together? And so now, what you see here is when there's differences across pay, 94% of workers say there will be conflict. Now, it doesn't specify here, at least in this version of the question, it doesn't specify whether that's to do with like underlying productivity differences, so why is it that some workers are paid different than others. However, it's very strong suggestive evidence that workers might be really unhappy and there will be conflict across workers if they're paid different wages in the same kind of team, or at least on the same construction site. And then, okay, of course, if you're like an employer, you might be quite worried about paying people different wages because if there's conflict, presumably workers will not work or collaborate as well as they could potentially. Okay, so now the authors set up a very nice field experiment that looks like this. So there's 10 production units of 3 workers each in each factories. So think of factories like work sites, factories in quotation marks, because it's really not just a factory as you might sort of imagine it. It's really like a small work site, an office where people are working in different areas. There's 10 units of 3 workers each, so it's not a huge office. Each unit of 3 workers produces different products. So like each unit has like one product. For example, unit 1 makes brooms, unit 2 makes incense sticks, unit 3 makes leaf plates, and so on. So each unit has like one item of production. Now, why are there different units? Is essentially to separate workers into different lines of work. So what we're going to expect is that workers are going to compare each other's within unit, but not so much across units, because if I make brooms and you make incense sticks, that's very different work in some ways. But if you make the exact same thing, the natural comparison now for a worker is to compare yourself with another worker. All unit members, so everybody in a given unit makes the exact same product. So everybody in unit 1, who has like 3 workers, makes brooms. Everybody in unit 2 makes incense sticks, and so on. Now, the key experimental variation in the experiment is wage dispersion across workers within teams. Finally, there's also, and I'll get back to that at the end, production tasks vary in their observability of performance. So that is to say, for some tasks, it just happens to be that it's much easier to understand how productive your coworker is than in other tasks. Okay. So now what is the variation in relative pay? So here you see people are paid depending on their worker rank. There's 4 different regimes of pay in the different columns: heterogeneous, compressed L, compressed M, and compressed H. Workers are sorted, so there's a baseline period where workers are worked for a few days, and the few days are used to assess their baseline productivity. They're ranked into 3 terciles. So there's like the low productivity workers, medium productivity, and high productivity workers. They're ranked essentially based on how well they did at baseline. Okay, so if you're like really bad to start with, you would be a low productivity worker. If you're like an average worker, you would be medium productivity. And if you're really like highly productive worker, you would be classified as high productivity workers. Notice that's always done for all of the different treatment groups. The difference now is across these different regimes how workers are paid. In the heterogeneous pay, essentially, there's differences in across workers in the sense that, like, the low productivity workers are paid a low wage, the medium productivity workers are paid a medium wage, and the high productivity workers are paid a high wage. As you might expect, that's sort of the natural thing to do in terms of you want to reward productivity. The most productive workers you're going to pay the most. Notice that these wage differences are modest, so even like the difference between a W high and W low are like only about like up to 10%. So really these are not huge differences. It's not that the other guy, if you are like a low productivity worker, or if you get W low, it's not the other guy gets like twice as much. It really is like modestly more, but it is more money that they get. Now then, if you look at the other three regimes, compressed L, compressed M, compressed H, low productivity, so in compressed L, everybody gets the low wage. In compressed M, everybody gets the medium wage. In compressed H, everybody gets the high wage. And now, the study now lets the authors compare the different columns for holding exactly constant baseline productivity and wage levels. That is to say, for instance, we can compare the heterogeneous, low productivity workers that happen to be randomized into like the heterogeneous treatment. They receive W low, or compare them with like low productivity workers at baseline who happen to be randomized into compressed L. So I should have said more clearly, people are randomized into any of these four groups, and then depending on what your baseline productivity is, you get the wages as I show here in the table. So for example, if you're like a low productivity worker, you might be randomized into the heterogeneous treatment group. You might receive W low, or you might be randomized into the low compressed low treatment, where you also receive W low. Notice that you're in both cases, that worker is a low productivity worker. In both cases, the worker receives W low. However, what's different here now is that his coworker, his or her, I think his in this case, these are all men, coworkers are receiving either the same, which is in compressed L, or they receive higher wages in the heterogeneous wage treatment. Right, so now we can look at like workers who have the exact same baseline productivity on average at least, and have the exact same wage, but what's being varied is like how much other workers are earning. We can do this for low productivity workers. We can also do it for medium productivity workers, or also for high productivity workers. I skipped the medium productivity worker, but that's exactly the same. For high productivity workers, we can look at the workers who have been randomized into the heterogeneous treatment group, or heterogeneous worker group, heterogeneous wage group, where the worker gets a WH, but everybody else gets like a lower wage. Or we can compare that to compressed H, where everybody gets WH in that group. Okay, so now what do the authors find? Let's start with the low productivity workers at baseline. Remember, the clean comparison here is between pay disparity, this is the heterogeneous group, pay disparity, and compressed L, which is like the group where everybody is paid the same. Now, what the authors find, and you see this in the graph fairly nicely, which is like the productivity, these are like the red line and the blue line, the productivity on the left side, this is before the treatment starts, for about over 10 days, the productivity looks pretty much the same. But then when you go to the right side of the graph, not immediately, but after a few days, there seem to be a gap emerges between the red line and the blue line, which is exactly the gap as you would expect if pay the disparity makes workers less productive, which is to say there are workers who receive a low wage, but others in their group are receiving higher wages, are becoming less productive compared to workers that receive a low wage where others have the exact same productivity. And you see this also in the regression tables. You see about a 22% reduction in mean output and a 9% reduction in earnings, which are pretty large effects. So these are like large effects compared to like other interventions that people have tried. Interesting, and you see a little bit like, well, the treatment effect, when you look at the graph, initially looks not particularly large. If anything, it might not even be there after like a few days. That treatment effect increases over time. It becomes larger. So over time, people become less and less productive compared to the compressed wage treatment. Interestingly, we find, or the authors find similar effects for high rank, high productivity workers. So notice that these are now workers who are high productivity workers. They receive the same wage in the pay disparity treatment and the compressed age treatment, that have the same wage. In one case, they are paid exactly the same. In the other case, they're paid more compared to their coworkers. And what happens to be, or what seems to be the case, is that the compressed high-pay workers, they're in fact more productive compared to others. You might have expected in some ways, like if one guy gets paid high payment and others get paid less, that makes the high-pay worker more productive because maybe he feels good about himself that he's a high-pay worker, or maybe he feels like he needs to prove himself or the like. But instead, what seems to be the case, the group that works in his team does not work well together, or it becomes uncomfortable to work with like somebody else who is like really mad at you for earning more than they do. And so now the high pay workers in the compressed treatment, in fact, earn more or produce more than the high pay workers in the pay disparity treatment. So that is to say, the pay disparity or pay inequality does not only reduce workers' productivity for the low-pay workers, so not only the people who work the workers who are earning less compared to their coworkers, and that's in some sense to be expected. You might just be mad that everybody else or other people in your group are earning more, and you might be unhappy and mad about that and just then produce less. Instead, it seems to be the case, even the high productivity workers, the workers who earn more than others in their group, are producing less compared to the control group where everybody earns the same. So what did we learn from that? Well, pay disparity lowers work performance for all team members. And so the interpretation of that is that pay disparity undermines workers' ability to cooperate in their own self-interest. The paper has some additional evidence with some cooperative tasks where essentially workers are worse at cooperating with each other. It seems to really be that workers are not happy to work in the same place with somebody else who earns less. Importantly, the perceived justification is essential in mediating these effects. That is to say, I told you previously that for some tasks, it was easier to see who's more productive than others, especially at baseline, just because in the task, the differences across highly and less highly productive or high and low productivity workers was just wider, and it's just easy to see that Frank is really bad at this and somebody else is really good. And for some tasks, it's really easy to see that, for others not. So if it's really easy, if there's a perceived justification for workers, if workers sort of thought, okay, it's really easy to see who was more productive than others, the effects are much weaker than when there's no perceived justification. That is to say, if workers themselves are saying, like, if I'm saying, like, look, there's this other worker who's really productive, and if I'm sort of saying, like, okay, look, this is really obvious that they're more productive than I am, it's only fair that they're earning more, then these effects are much dampened. There's much less an effect. It's accepted, and there's much less of a productivity effect, if any, if there's pay inequality. However, if it seems to be the case that we're kind of like producing the same thing, and we're like we're producing the same thing and we're equally good at it or approximately equally good, and one person is paid more than I am for no good reason, so it appears, then workers are really not happy about that, and work performance, in particular output, falls. So what are the implications? Well, this evidence sort of suggests that wage compression may be more likely in some settings than in others, right? That's to say, like, if it's easy to justify, if the production function or like the production process is such that all aspects of the production and the output or the performance are easily measurable and observable for workers, then workers might say it's okay if some workers are earning more than others. However, if that's not the case, if there's a bunch of stuff in the work process that's really not observed, maybe it's verbal or maybe it's just really hard to justify or hard to sort of assess in some tangible way, then workers might be really unhappy, and that might lead to wage compression because the employer might anticipate that. So overall, this sort of says that relative comparisons matter quite a bit. Fairness matters quite a bit. And what's really key for an employer or anybody who sets incentives is to take into account these fairness considerations, and one wants to really understand what is fair and what is not, and upsetting workers by violating these fairness considerations or norms might be really, really costly for an employer. So the good news here is that if one understands that well, one can really sort of increase productivity quite a bit. And in some cases, wage inequality is actually fine. One just has to be careful in figuring out when exactly is that the case. Okay. As I said, there's a very nice paper by Jonas Hjort on ethnic divisions in production in firms. We're going to talk about that in recitation. The second part of this lecture will talk about policies to increase pro-sociality. And so the first of these papers is a very nice recent paper by Gautam Rao that looks at the question, are social preferences malleable? What are the origins of social preferences? Why is it that some people appear nicer than others? And then, once we understand that, perhaps we can also understand what policies, if anything, can affect social preferences. The main question that this paper asks is, how does being mixed with poor students in school affect the social preferences of rich students? Now, in a lot of kind of policies where poor students are mixed with rich students, you might ask the question, how does it affect the poor student? If a poor student, for whatever reason, would not be able to afford a rich school or a rich student school, and you sort of allow them by giving them scholarships or other policies, often the question that people ask is what are the benefits of doing that? Is the poor student doing better in school? Or do they have different types of friends, different networks, and does that lead to better jobs, and so on and so forth? This paper asks a different question. It asks the question about what is the effect of rich students if they randomly or quasi-randomly are exposed to being in class with additional or some more poor students. The paper exploits a policy change that introduced an admissions quota of 20% for poor students in primary schools in Delhi. These are rich private primary schools. The paper looks at two sources of variation. There's variation across classrooms that allows the author to look at the overall effects. So you can look at within schools, there's going to be treated uncontrolled cohorts because the policy was introduced at some point. So for some students, they enjoyed the benefit of being in class with poor students, or the costs, we'll see about that. And for other schools, they're already too far advanced. They were essentially they went to school before the policy was enacted, and therefore they were not exposed to having poor students in school. For these treated schools, there's essentially variation within school across cohorts that we can look at. Second, within cohorts, we can look at treated and controlled schools. So some schools were getting additional poor kids, and others did not. I'll tell you about this in a second. And then there's variation within classrooms to allow us to look at the role of personal interactions. There's sort of idiosyncratic assignments to study groups. So some students happen to be in study groups with a poor kid, and others were not. Now, what does the study measure? The study measures three broad set of outcomes. It measures pro-social behavior and generosity. This is very much what we have already looked at. In particular, it looks at dictator games and volunteering for charities at school. The paper has a very nice mix of laboratory outcomes sort of measured in the field, which is sort of the dictator games that you're all familiar with. And field outcomes, which is sort of trying to collect real-world outcomes in the sense of like things that are perhaps somewhat less contrived from the perspective of like kids in school. And what's very nice about the study is that it seems to be that the results are very much aligned between sort of these lab outcomes, the dictator game type outcomes, and the field outcomes, which is volunteering for charity at school in this case. Second, the author looks at discrimination in social interactions. In particular, he does a little sports contest and looks at teammate selection among these students, and then willingness to attend play dates with poor students. Finally, the author also looks at academic outcomes, in particular test scores and disciplinary infractions. Now, why might one want to look at academic outcomes and why we're interested in social preferences? There's several reasons for that. In particular, an important reason here is that if you're against this type of policy, I might sort of show you that, oh, you know, adding poor children might affect the social preference of rich children and so on in various ways. Maybe discrimination goes down. But perhaps it's the case that that all comes at the cost of academic performance. Right? If you're trying to sort of implement this policy and you know, persuade policymakers, maybe teachers, or parents of like, okay, let's have more poor students in your school. Well, parents might sort of be, okay, fine, there's going to be like some change in social preferences, some change in discrimination, but really what we care about is test scores or discipline at school, and these poor kids might not be, might be worse in terms of like test scores, and they might have like negative peer effects in terms of like test scores, but also in terms of disciplinary infractions. And sort of as a policy question, then it's really important to understand if there are some benefits in terms of pro-sociality or reduced discrimination, do these benefits come at the cost of reduced academic performance? So now, what is in fact the policy innovation in Delhi in 2007? There was a 20% admissions quota in private schools introduced for poor students in some of these private schools. There's a household income cutoff of $2,000 per year. So these are not sort of the poorest of the poor of the students who are qualified. Schools which received subsidized land from the government were essentially included in this policy change. That's over 90% of elite private schools. So think of these elite private schools. These are really sort of like very rich kids or parents of these kids. There was no fees for the poor kids because, you know, they would not be able to afford these fees anyway. There was importantly also no tracking. So it wasn't that like high ability or high performance kids who do very well were like tracked into like high tracks and the good tracks versus lower tracks. Instead, everybody was mixed together, poor and rich, high performing, low performing students. And the poor kids were selected using lotteries, which in principle also allows the author or others to look at the effect on those poor kids, the students who are selected versus not. To be clear, this is not the subject of this paper. Just to give you a sense of the magnitude of like the mixing, you see I said the average beneficiary was sort of at the 25th percentile of the income distribution in Delhi, and wealthy students are very much on the right tail. Sorry, on the right tail of the distribution, something like the 90th percentile, 95th percentile, which is about the US equivalent of that would be about $200,000 per year. The average beneficiary had like a US equivalent income of like $23,000. Again, these are not the poorest of the poor, but relatively poor. It's about like an order of magnitude poorer than the average person in the actual school. Now, this policy then induced large variation across classrooms. If you look at poor students in the fraction of, or the number, sorry, of poor students by grade in 2011, I told you this, the policy innovation was in 2007. So if you look in 2011, that's 4 years later, anybody who is in grade 4 in 2011 has essentially no poor student in their class in those rich schools. So for students who are in 2011 in grade 4, 5, or 6, that policy came too late. They do not have any poor classmates. In contrast, if you look at the lower grades, grades 3, 2, 1, and 0, which are essentially preschool, or 0, -1, which is preschool grades, there's lots of additional poor students now in those rich schools. Now, again, there's variation within schools and across schools. The variation within schools is across classrooms. That's kind of what I'm showing you here. But there's also variation across schools. So just to be clear, the variation within schools across classrooms is like in the treated schools, there's some classes like the 4th grade have like essentially 0 poor kids in their classes, and the 3rd grade in contrast have lots of poor kids in the classroom. We can do that comparison across classrooms within school. In addition, there's also variation across schools. There's in particular, there's treatment schools, which comply in 2007 as they were supposed to. But then there's also delayed treatment schools, which complied in 2008. So the jump shifted by one cohort. So the jump that I showed you here, this is for the treatment schools that complied, or this is for everybody that complied in 2007. The delayed one complied a year later, so you'll see them essentially somewhat later increasing, or 1 year later exactly, increasing the fraction of poor kids in their classroom. And then there's the control schools. They were not subject to the policy, at least until 2013. So they had received land from federal government or private foundations. So essentially there was no treatment. That is, all students are rich in these types of classes. So that was the land receiving is essentially just, that was like a fairly arbitrary rule in some ways. So that sort of leads to at least quasi-random variation. In some schools received the treatment and others did not. Now let me show you some outcomes. So one outcome is our friend the dictator game, which you've seen quite a bit and played already as well, is students are allowed with 10 rupees, which is, not very much. That's about like 15 cents. And they choose to share, notice that these are pretty young kids, so 10 rupees is quite a bit of money for them. They choose to share an amount as before between 0 and 10. And Gautam sets this up such that students could, it was not just about the money, but they also can exchange the money for candy later at 1 rupee per piece, so that was a pretty good deal. Then the dictator games for the order was randomized. The kids would play 2 games. Again, these are all rich kids who do that. They play first game 1, where the recipient is a poor student in a school for poor children. And in game 2, it's a rich student in a private control school. Notice it's a control school, to be clear, so it's not a kid that they might know. So the kids are chosen such that the kids were given the names and the photographs of the school shown to the subject, to the kids. So you could sort of see, and this is verified in the briefing by the author, is that the children understand very well who's a rich kid and who's a poor kid, but these are not kids that they would actually know. And something that's a less interesting question, if you have gone to school with somebody for a long time, you might have seen them around in your schoolyard. You might be nicer to them or less nice to them. That's not what the study is looking at. The study is looking at other kids in other schools that look rich or look poor, both in terms of like the way they're dressed and so on, but in particular the way their school looks like. So essentially these are, now we're looking at social preferences towards other people, people that these kids don't know. Okay, So now what do we see? So this is a generosity to the poor. So like this is essentially the results from game number 1. Again, remember, these are all rich kids who are giving now to poor kids. And the question now is being exposed to, or does being exposed to poor children for several years, does that affect giving in the form of dictator games towards poor children to start with? We're going to talk about rich students after that. So here you see the generosity to the poor and controlled schools. You see this is the percent given to the poor recipient. It's remarkably similar to what we've seen previously, which is about 20 to 30%. About 25% is given to the poor kid in the control groups, in the control schools. This fraction seems to trend up a little bit over time, but it's also quite constant over time across grades. You see here grades 2, 3, 4, and 5 on the x-axis. On the y-axis is the percent given to the poor recipients. Now, adding the treatment schools, now we find that for 2 grades, for grade 2 and grade 3, remember the graph that I showed you here. You see that in grades 3, 2, 1, and so on, these are the kids who are exposed to the poor children in class, in contrast to grades 4 and 5 that have not been exposed to poor kids in their class. So what this graph now shows is that exactly the grades 3 and 2 that have been exposed in the treatment groups, that have been exposed to poor classmates, these are exactly the students, the grades where giving is higher towards the poor compared to the control groups, but also compared to the older cohorts 4 and 5, the grade 4 and 5. When you look at grades 4 and 5, there you see essentially no difference between treatment and control schools. So they seem to be very similar. In contrast, if you look at grades 3 and 2, where the treatment kids are exposed to the treatment by having the poor kids in their classrooms, these are exactly the years where giving goes up, and goes up by quite a bit. While the average was, as I said before, about 25%, that goes up to about 35%, so that's a pretty large relative increase. Now, in addition, as I told you, there are also delayed treatment groups, treatment schools. So for those schools, if you were in grade 3, it was also too late for you because the treatment was introduced only a year later. So if you were in grade 3, you did not have any poor kids in your school. Now, if you look at the yellow line here, the yellow line looks very much like the green line. That is, for the delayed treatment schools, there's no impact either. They look very much like the control schools, as you would expect. However, in the delayed treatment schools, in grade number 2, that's the grade where the students are exposed, the rich students are exposed to the poor kids. You see essentially similar effects to the treatment schools as you expect. So that's fairly compelling evidence that really the differences that you see across these schools are driven by the treatment that was on the timing of the treatment, as opposed to other potential effects due to, like, selection, or maybe these schools are different and so on. We see essentially no differences in grades 4 and 5 for any of the treatment and control schools. We also see no difference in grade 3 for the delayed treatment schools compared to the control group. In contrast, we see clear differences in grade 2 for the delayed and the treatment schools compared to the control schools. We also see a clear difference for the treatment schools compared to both the control schools and the delayed treatment schools as well. So that's fairly compelling evidence that game or play in dictator games changes when students are exposed for quite a long time to poor kids in their classroom. Okay, so now, in addition, we will have variation within classrooms. So what I show you here, this is all variation across classrooms. That is to say, if you have a poor kid in your classroom, you will behave differently, or that will change your attitudes or your giving in dictator games towards the poor or other poor children. Now, in addition, the author also has evidence of variation within classroom. Now, let you think about for a second, why is it important to also have variation within classroom? Isn't the evidence that we have here already compelling enough? Why do we need more? And you can think about this for a second. The reason for that is that the diff and diff, the difference in differences, comparing essentially across classrooms, identifies the overall effect of having poor classmates in class. That might be the result of like personal interactions, but it might also be the result of like the teacher, the curriculum might change, your parents might change in some ways, and just telling you like, look, there's these poor kids in your class. The teachers might tell everybody, oh, you need to be nice to poor kids. The curriculum might change. It might sort of include things that tell you to be nice to poor kids and so on. You might be sort of exposed to just different types of material. So really, given the evidence that we have here, when you just compare across classrooms, you cannot disentangle whether this is driven from like being personally exposed in terms of interacting with poor children personally by just talking to them in certain ways, or being exposed to them, or like learning about them and so on. So it cannot disentangle personal interactions from teacher or curriculum changes that are essentially at the classroom level. So in addition then, Gautam also has within classroom strategy that exploits the assignment to study groups. What is that doing is essentially it isolates the role of direct personal interactions and is not subject to sorting concerns. Another concern might be that, you know, you might sort of say, oh, in this school, they're having like poor kids that are let into this private school. I'm going to send my kids to somebody else. So that's also an issue, perhaps potentially in the evidence that I showed you before across classrooms. The within classroom strategy is now looking at everybody who's in that classroom and looking at some kids where they're just randomly assigned to be in study groups with poor kids and others were not. And that sort of allows to disentangle or allows to isolate the effect of personal interactions. So 1 hour a day, kids were working in small groups of 2 to 4 students. Remember, this is for a very long period of time. So like, you know, it's 1 hour per day, but it was also like for quite a bit of time. It's not just like doing that once or twice, it's for like an extended period of time. And crucially, some schools use the alphabetic order of first names to assign study groups. So that's essentially exogenous variation in personal interactions. Other schools frequently shuffled the groups and only, which essentially sort of everybody was equally exposed to those kinds of, to different students. So you were sometimes in study groups with rich students only and sometimes with poor students only. In the first group, where the alphabetic order was used, you were either sort of in the study group where you happened to be next to somebody who's a poor kid because they happen to be next to you in the alphabet, or you're not, and that stayed the same. Now, what does this let us look at? Essentially, the alphabetic order predicts study partners. So now you might say people with different names might also be different. So it could just be that like my name, because my name is different, I'm more likely to be next in the alphabet to a poor student. For example, if I'm a rich kid and there's some names that are like more similar to poor kids' names, it could be that my parents are particularly tolerant. They also gave me a name that sounds like a poor person, and therefore I'm more likely to be in a study group with a poor other poor kid. It's not, and that's not then the impact of being in the study group, but rather sort of selection just could be that names are different or people with different names are different. So that's why having this control group is really nice. So what we can look at now is to say we can look at kids that have names adjacent to rich students and kids that have names adjacent to poor students. So if you look at the left side, it's essentially looking at students that have their names adjacent to rich students only, or students that have names adjacent to also some poor students. When you look at that, where the alphabetic order was not used, the outcome here is now, what's your share of having poor study partners? And so there, essentially, there's no difference, as it should be, because the alphabetic order was not used. They was just shuffling around the kids all the time. So it didn't really matter what your alphabet was. It didn't really matter. But crucially, we can still look at the alphabet. We can look at kids that have names where adjacent in the alphabet there's only rich kids, rich students, or we can look at kids that have names where adjacent to the alphabets there are poor students. And here you see on the left side of the graph, you see essentially no difference across these groups. So they were equally likely to have a poor kid in their study group. In contrast, on the right side of the graph, you see the alphabetic order was used to assign study groups. So if you had a name adjacent to a poor student in the alphabet, you're very, very likely to have a poor kid assigned to you or be in your study group. Not always, because sometimes these are groups of 3, so that sometimes you were lucky or unlucky, depending on how you view it. There were just the group was like just above you or below you in the alphabet. But most of the time, if you have a name adjacent to a poor student, that student or any poor student would be in your study group. If you didn't have a name adjacent to you, or if you only had like rich student adjacent to you, there's still a chance that you have a poor student in your study group, because it could be just like, not the person next to you, but the person, another person further down is in fact a poor student. You end up in that group with that student. Remember, these are groups of 2 to 4 students, so it could just be that you're in a group of 3 to 4 students and not the person adjacent to you, but the person after that ends up in your study group. So you're still likely to have, you have still about a 40% chance of having a poor kid in your study group, but there's a huge difference between the 2 types of groups. The name adjacent to the study group has huge fraction, about 90%, or versus 40%. So crucially, now we can compare for both types of schools, for the schools on the right-hand side, where essentially the names are very predictive of having a poor kid in your study group, versus on the left-hand side, where the names are not predictive at all, whether you have a poor kid in your study group. And so we can, that way we can keep selection the same. The types of name are the same. We are isolating the impact of having a poor kid in your study group. Now, what does the author find? He finds that this is what we showed you before, which is about, in the control group, we had about, in the dictator game, these kids gave about 27%, having a poor kid in your classroom. That's the evidence that I already showed you. The treatment effect is about 12 percentage points. That's fairly large. That's almost like a 50% increase, a little bit less than that. So that's a huge increase. And then in addition, when you look at kids that have a poor study partner, notice that these are things not necessarily additive, but you have a poor study partner versus not, there's an effect of about 7.5 percentage points. That's a pretty large effect. So both of these things seem to matter. Personal interactions seem to be quite important, but in addition, there seem to be also some additional effects, perhaps coming from the classroom level. So there's 2 types of effects that are possible here. Some types of effects could be from the teacher, parents, curriculum, etc. might be different. Or other things could be just like, even if you don't have a poor kid in your study group, you might still play with them or be friends with them, or just seeing them around in your classroom might affect you. But crucially, the personal interactions seem to be very important as well. Now, one question you might ask is, well, so far I showed you generosity towards poor children, right? So that was game number 1. We looked at what happens in the dictator games when a rich kid plays with a poor kid, and the rich kids become nicer towards the poor kids. Now, how about generosity towards other wealthy children? Well, it turns out that increases as well. there's a smaller effect size, but it's still substantial and in fact statistically significant. So why might that be? You might sort of ask, well, what's going on here? So here's the evidence. You sort of see the change in giving to rich participants. This is sort of like a distribution. You see this is the share giving to the rich participant. It seems to be what happens. These are essentially the fraction of students in the different treatment versus control who give 0, 10, 20, 30, 40, 50%. And what you see, there's about a 10 percentage points decrease in the fraction who give 0, and about 8-something percentage points increase in the fraction who give 50%. So it seems to be that there's quite a few students who move from 0%, about 10% of them, move from 0% to 50%, and 50-50 is kind of like the equal allocation. So rich kids are also becoming nicer towards rich kids in these dictator games. So what's going on here? There's different potential explanations. Perhaps the most plausible explanation, the study has some evidence on that. At the end of the day, it's hard to sort of entirely nail this or rule out all other potential explanation. But it's quite plausible that what's happening here is that inequity, students, when you're exposed to poor children, you are essentially more averse to inequality or inequity across people, even in fairly trivial things that are such as dictator games. Now, I told you before that's a little bit funny because dictator games obviously are very narrowly framing people and looking at essentially very narrow outcomes. If we have a 50-50 outcome in the dictator game, that doesn't mean that our life is the same. It might be you might be still much richer than I am. So having sort of equal outcomes in the dictator game, 50-50 allocation in the dictator game might be narrowly framed in that particular game fair, but of course it's not fair in the grand scheme of things. But what seems to be the case is that, and there's some other evidence in the paper that you can read if you would like, it seems to be the case that rich children become more averse to unequal outcomes in the world in general because they essentially see these poor kids who are very smart and are disadvantaged in terms of various ways from having a lower wealth of their parents. The rich kids become sort of more averse against that, and that translates even into dictator games with other rich kids in a very sort of minor thing in the world in these dictator games. Again, even though the dictator games actually don't change very much. But they really seem to be averse to inequality of these outcomes and move then from the 10-0 allocation to 50-50, even with these rich kids. Okay. So that was evidence on social preferences as measured by dictator games. The paper also has some evidence on discrimination, in particular a small field experiment on team selection. So what does the study do? So the subjects are, again, students from 2 elite private schools. So now it's 2 of these selected schools are selected. One is a treatment school, one is a control group. And in addition, Gautam invited athletic poor students from a public school. Importantly, these are athletic students. These are students who are better at sports than the rich kids. You might think, the poor kids are better at sports than the rich kids anyway, which is probably true. But now these are particularly athletic students on purpose who are invited to attend a sports event as well. Now, students in this experiment, in this game, must choose teammates to run a relay race. Now, when you know a rich kid who is thinking about who should be in my team, you can either choose a rich kid who is kind of similar to you in social ways, or you can choose a poor kid whom you don't know very much. You might actually not like the poor kids, but the poor kid is a lot better in the running, so it might be much better for you. You might be much more likely to win in the game because now your partner in the relay race is much faster. So it's a very nice trade-off between ability, choosing the fast runner, versus social similarity. And now what Gautam then is doing is if you sort of choose the rich kid, that's then a measure of discrimination because essentially you're choosing a worse runner in favor of like, or because you want more social similarity, you don't want to hang out with a poor kid. Instead, you choose the rich kid, which reduces your chances in the race, but increases your time spent with the rich kids compared to like poor kids. Let me tell you a little bit more detail of the experiment. Stage one is randomization. So it was the people were randomized to sessions with varying stakes. There's 50 rupees, 200 rupees, 500 rupees per student for the winning team. This is a lot of money compared to like students' usual pocket money, right? So they would get something like $10 or 500 rupees is like 1 month of pocket money. So that's like really high stakes for these kids. The price is varied essentially because it lets us like price out, it gives us a price of discrimination, lets us understand how much are students willing to give up in order to not have to, or in order to be able to socialize with the rich kids compared to the poor kid. There was brief mixing to start with to judge socioeconomic status, right? So the kids were like allowed to mingle a little bit. That would allow them to fairly easily understand who is a poor kid and who's a rich kid. Okay, stage number two was ability revelation and team selection. So you could essentially observe a two-person race. Usually it's one poor and one rich students. Neither is from the own school, so these are not students that you would know from school anyway. But the uniforms make the school identifiable. Do you kind of know who's the rich kid and who's the poor kid? Now, then you can pick which of these two runners you want to have as your partners. So that is to say, you see them run one by one. It's very easy to see like who's faster and who's not. And so again, discrimination here is interpreted as like picking the slow runner. So if you pick the slower runner, and then it must be because you like something, some other characteristics about that person more. The obvious characteristic here is that it's most likely going to be that kid is rich. Okay, then stages 3 and 4 are the choice implementation relay race. So students are randomly picked to have their choices implemented. So some of those choices, this is again the strategy method, some of these choices were actually randomly implemented. So there's plausible deniability for the students in the sense of like, you could just you could just happen to be randomized, or you happen to pick some students versus another. Could just be by chance that you are with one student versus another. So you're free to choose. Essentially provides you cover. Sometimes, as we discussed before, the computer is choosing, so you always have an excuse. So it's intended to reveal students' true preferences as opposed to perhaps what they think that their friends want them to choose, or the other runners. Then the relay races were actually held and prizes were distributed as promised. Number 4, crucially, there was a social interaction. So if you picked like your teammate, you actually have to spend 2 hours of playing with a teammate, board games, sports, playgrounds, and so on. Importantly, this was pre-announced. So now, again, as I said before, when picking your partner, you have the choice between either picking the fast, poor kid, which will really increase your probability of winning, or the rich kid who's kind of slow and will reduce your probability of winning. But if you pick that poor kid or the rich kid, you have to actually spend 2 hours with that teammate playing board games, sports, playground, and so on. And you might not want to do that with a poor kid. Okay. So now first, what is demand for discrimination? You can look at this graph, shows very nicely for the different prices. As I said, 500 rupees for winning the race, 200 rupees or 500 rupees. If you look at 500 rupees, this is again 1 month of pocket money. There's no difference between treated and non-treated classrooms. That is to say, so there's 10% of people are, if you want, discriminating the poor. So 10%, or sorry, this is less than 10%, is about 7-8% of students pick the rich kids, even in the really, really high stakes race. That is to say, when the stakes are 500 rupees, they're like about 6, 7, 8% of students who still pick the rich kid, and they sort of take into account the chance that that might lose them the race, but they don't have to spend 2 hours with a poor kid then socializing. Now, when you look at the lower prices, the fraction, as you expect, this is the red line, this is the green line, the upper line, the fraction who choose the rich kids, the fraction who are discriminating against the poor increases as you expect. So now it becomes cheaper. It's only like the raise is only 200 rupees or 50 rupees. You might be more inclined to pick the rich kid because, you know, the value of socializing stays the same, but the cost of picking the rich kid, the cost of losing the race, potentially at least, is reduced, right? And sort of, if you look at 50 rupees, the price 50 rupees for the game, for the relay race, that's about almost like 40% of students now pick the rich kid, even though that might lose them the race. And now, crucially, in red, this is the dashed line below, you can see the treated classrooms. And what he finds is that for 500 rupees, when the stakes are really, really high, there's no effect. Essentially, it doesn't really matter whether you're in a treated or non-treated classroom, in part perhaps because there's not much room for going lower than that. So essentially, there's no effect on there because, you know, the stakes are really, really high. Anyway, there's not much discrimination, and having had a treated class, having had a poor kid in your classroom doesn't really change that. But then very clearly for 200 rupees and 50 rupees, the lower stakes, there's a clear difference between the green and the red lines. That is to say, there's a lot less discrimination towards the poor kids. Poor kids are a lot more likely to be chosen when a student had, in treated classrooms, when somebody had a poor kid, another poor kid in their classroom for several years. So that's to say, there's being exposed to these poor children reduces discrimination among the poor, among the rich students subsequently. This is sort of the same graph that I showed you before. Again, that's sort of consistent with what we had before. It gets a little messier than we had seen previously, but similarly, even within classrooms, if you look at like grades 2 and 3 versus 4 and 5, the effects seem to be concentrated, more pronounced in grades 2 and 3. Now, finally, as I said, we look at test scores and discipline. So arguably, there's some positive effects on social preferences. And as I said before, the policy question now is, does that come at the cost of academic achievement in some ways? So is it that your rich kid now, by being exposed to the poor kids, maybe is somewhat nicer and more friendly and less discriminating against the poor? That's all in good. But is it the case now that test scores go down? So Gautam finds no effect on an aggregate test score index. There's zero effect on Hindi and math. There's a little bit of like a reduction in English scores of 0.09 standard deviations. That's marginally significant. You know, that's suggestive, but not perhaps particularly large. So these effects are not particularly large, and in particular in aggregate. So if you aggregate everything together, there don't seem to be any significant effects. So perhaps the English scores are suggestive, but sort of not particularly large. There are some mild effects on discipline. Interestingly, there's an increase in swearing. You think that's good or bad? You can think about that. But sort of there seems to be a little bit of effect of like in terms of like language usage. There's no effects on violent and disruptive behavior, which you might think is like a lot more damaging potentially. Okay, so just summarizing, what does the paper find? Well, having poor classmates makes wealthy students more pro-social and generous. They're more likely to volunteer for charities. I didn't show you that evidence, but that's another piece of evidence that he finds. They're more likely to give in money in dictator games, to give more higher fractions of their share in dictator games. They also choose more equitable outcomes in sort of disinterested third-party games, where essentially you choose between two other students and their allocation. So it's not just that they're more likely to willing to give up money that others get, but also they're more likely to choose equal allocations in third-party games and disinterested games. Again, I didn't show you that evidence, but it seems to be that what's increasing here is sort of like inequality aversion and these sort of disinterested dictator or other types of games, where essentially these students, by being exposed to poor kids, are now more averse against unequal outcomes in these types of games. Second, there's like less discrimination and more higher willingness to socialize with the poor. They're more likely to choose poor teammates in sports contests. They're also more willing to attend play dates with poor children. Again, I didn't show you that evidence. And then there's like some small negative effects in academic outcomes that I think are mostly negligible. Now, there's another work on the contact hypothesis, which I showed you. So what is the contact hypothesis? The contact hypothesis is from, goes back to at least Alport in 1954, which is the idea that interpersonal contacts reduces prejudice until certain conditions, and not just prejudice, but also changes attitudes and social preferences potentially. So Matt Lowe, who was a PhD student here at MIT, has a very nice paper that looks at cricket tournaments and asks the question whether cricket leagues in India can increase cross-caste interaction and pro-sociality. So what he does is he randomizes essentially cricket leagues and teams in cricket leagues where people across different castes are now more or less likely to play with each other, both in terms of like, he varies, or there's variation in the study within teams. So are you more or less likely to have some people are more or less likely to have a lower or higher caste, a person from a different caste in their team. And he has variation in what he calls adversarial contact, which is like they're more or less likely to be exposed to players from other teams in higher or different castes from themselves, right? So if you're on the team and have like a person from a different caste on your team, you're on the same team. You share the same objective and you want to win together. So now having somebody from a different caste or just somebody who's different in various ways in your team might make you like them better. You might be sort of more positive about them. You might be sort of more likely to talk to them. You might learn about them. You might sort of see some sides in them that you hadn't seen before. So you might be more likely to sort of empathize and look at sort of nice characteristics of them and sort of update them positively about people from other tasks, and that changes your attitudes towards them in general. If, however, you play against somebody from different castes, that might actually, if anything, backfire because you really don't like your opponents. You might see them very negatively. You might be aggressive towards them. You might be unfriendly towards them. You might sort of not like it that they win against you or the like. So these adversarial interactions might actually backfire in the sense that they might not foster integration, but actually sort of make things worse. So Matt runs this experiment and finds evidence of increased cross-caste interaction. So people are more likely to be friends, more likely to hang out with others. They also are more generous in dictator and other types of games. They're also more likely to engage in trade or in economic exchange. So what Matt does is sort of he randomizes gloves. So there's like left gloves and right gloves, and he has the same for flip-flops, left flip-flops and right flip-flops. And people are more likely to trade with somebody from another caste if they have been on the same team with people from other castes. If they have a higher fraction of people on their team of people from other castes, they're more likely to engage in all these behaviors. They're more likely to have cross-caste interaction, more likely to be pro-social, more likely to engage in economic exchange with people from other castes. So that's all true for collaborative contact. That is to say, it's contact with people on the same team. In contrast, for adversarial interactions, when people are in the opposite team, having more people from other castes or being exposed to more people from other castes does not have these positive effects, and for some of these outcomes have even negative effects. So if anything, it sort of backfires. It doesn't just a mere exposure to others, if you were sort of in an adversarial contact situation, does not really foster pro-sociality or any of these types of integration. If anything, it backfires. Now, why is that important? If you think about, like, for example, attitudes towards immigrants, it really matters hugely what types of contacts people are exposed to. If people work together in the same team, if they have perhaps like team pay, if they want to like work towards the same goal, really that can, it seems as evidence suggests, can foster pro-sociality and so on and so forth. That leads to integration, reduce discrimination, and so on and so forth. So if sort of the incentives are aligned, or if we could sort of set up incentives that are aligned, people might become nicer to each other, and interactions might be fostered. In contrast, if contact is adversarial, if you're worried that immigrants are taking away your jobs or the like, being exposed to immigrants might just do the opposite. Right? So you might see a lot of immigrants, but in a way, if you feel like you're in competition with them, if they're adversarial, if they're sort of your enemies in some ways, or your opponents in like some competition for a job, being exposed to them might things, in fact, if anything, worse. Finally, there's another piece of very nice evidence by Corno et al. This paper is considering the impact of random interracial interactions among college roommates in South Africa on stereotypes, attitudes, and performance. What they look at essentially is roommates of different race. Reduces, so these are black and white students, reduces white students' stereotypes towards blacks and increases interracial friendships. It also improves grades and lowers dropouts among blacks, so there's sort of a number of positive effects of a very simple policy of like increasing contacts among roommates. And again, if you think about this evidence, it seems to suggest that perhaps that's kind of like if you have a roommate that you're going to live with for quite a while, that feels a lot like collaborative contact in the sense of like you're sort of stuck with that roommate for quite a while, so you might as well sort of make the best out of it, even if you initially don't like that person, and you have the same objectives of being happy together or living together, and that really seems to foster and have some positive benefits. So taking together, that sort of says, the contact hypothesis seems to be broadly right. Contact to people who are different from you might make you more tolerant or more pro-social towards them. There might be more sort of integration of different groups. But what really seems to matter quite a bit is the type of contact that people are exposed to. Okay, so finally, and relatively quickly, I'll tell you a little bit about whether people underestimate the benefits of pro-sociality. I should mention that problem set 3, question 2 is, in fact, trying to ask you to do something related to that. So you might want to actually do the problem set first before you finish this lecture, at least sort of, sorry, not the entire problem set, but like question 2 of problem set 3. That will not take you very long to do so, and it's more like a fun exercise that I thought would be nice for you to engage in. But anyway, this is a very nice paper by Kumar and Epley. So that's a typo here. It should say Kumar and Epley. And the authors asked the question about, do we have correct beliefs about the impacts of generosity? And so what's the underlying reason here is, well, many pro-social acts require estimating the impacts on the recipient. Right? If you give money to somebody in Africa, if you help any people in need, if you donate money in general, if you write letters of gratitude, or if you do random acts of kindness, it requires some sort of estimation of how is the other person going to feel if they receive, if they're on the receiving end of this pro-social act. Now, what Epley and Kumar argue is people are subject to egocentric bias, which may lead them to systematically underestimate the positive impacts of pro-sociality. In this case, gratitude letters. And so why is that? Well, it's because predicting others' mental states is difficult. It's really hard to for people to understand how another person might feel. Usually people would sort of think about themselves and sort of think about how would I feel and what would things be and how are things like. And it's very hard to understand how others might react to you. It sort of requires perspective taking, and that's sometimes tricky for people to do. So this is, again, a very nice experiment by Kumar and Nicholas Apley, not Nicholas' last name, but Nick Apley. And they test whether people misunderstand the consequences of showing appreciation. And so what are these experiments? There's a series of experiments that look at this. What do they look like? Well, what they do is, like, they ask people, MBA students or other subjects in experiments, to pick a pro-social act. That's writing a gratitude letter, for example. And then ask how the giver and the recipient will be affected. In some cases, it's only the recipient. In some cases, it's also the giver. Then they perform the pro-social act by, for example, writing a letter of gratitude, and then assess how the giver and the recipients were actually affected by doing that. And then you can compare that to item number 2, to the estimation ex ante. Now, what do they find? They find clear evidence that when you look at, like, in particular, when you look at the giver, so these graphs all show kind of like the predicted ratings. The ratings is between 0 and 10 about, like, what's the experience, how happy is the other person, what is the surprise about receiving this letter of gratitude in this example. So people are more surprised than predicted. They're also more surprised about the content than predicted. They're also, the recipient's mood is actually better than predicted, and the awkwardness is also better than predicted. So when you ask people to write, like, letters of gratitude, people tend to say, oh, you know, like, it's going to be, like, tedious to do, and, like, the other person might feel it's awkward, and what am I going to say, and is it going to be weird what I'm going to say? Is the person, don't they know already anyway that I'm really appreciate of that person, and so on. So people come up with all sorts of reasons why they might not want to do that. If you sort of introspect and ask yourself, how many letters of gratitude have you written in the last year? That doesn't, few people actually do that in practice. And perhaps some of these reasons, like the perceived awkwardness, or perhaps sort of the underestimation of the recipient's mood, might contribute to that. Now, if you also think for a little bit, like, how would one actually feel to receive these letters? It's pretty obvious once you think about it that most people are actually quite happy about receiving such letters. It's kind of nice if somebody tells you, look, you did something really nice for me sometime, like a long time ago, and, you know, this helped me a lot in my career in whatever ways, or like in getting into school, into like college, or whatever it might be. It's really nice to sort of hear from somebody that you did something nice in their life that people are quite happy about. Now, what sort of like some evidence, some summary of that? Well, so we tend to systematically underestimate others' appreciations in expressions of gratitude. That's also true for some other types of effects. That tends to be also true for, like, random acts of kindness. People tend to be surprisingly more happy about those compared to predicted. It's also true, so Apley and Schroeder argue, for social connections. So people also underestimate, on average, how they themselves and others feel when starting conversations. So what this experiment does is it gets people to, it randomizes people to start conversations during commuting on buses or trains. And once people start doing that, again, before, when you ask them, like, you know, how is the other person going to feel? How are you going to feel? And so on. People will say, well, it's going to be awkward, and, like, what are we going to talk about? And is the other person even interested? And so on. But once you actually do that, people seem to be quite happy to have started conversations and making human connection. To be clear, not everybody is happy. Some people might be also grumpy, but the vast majority, at least in these types of study, seem to be quite happy about initiating social contact, about expressions, letters of gratitude, or things like random acts of kindness. It's really nice if somebody happens to be to do something nice towards you. It could be like a random person who you've never seen before and you never see again. Just some random person on the street is really nice to you. That might make your day. It could be also somebody who you know quite well, and he's a good friend, and who just wants to do something nice for you for no good apparent reasons. So one caveat to these kinds of experiments is these are very much like short interactions. These are one-time interactions, and then the effects are measured. So there are some questions about do these effects persist for repeat interactions? That is to say, like, Maybe if you do that once, people are quite happy, but when you try it more often, these effects tend to go away. So there's a bit of a question kind of like how persistent, how important are these in practice if you do that more often, in particular in the long run. And then another important question here is then the question about are we underinvesting in pro-sociality in terms of our behavior? So lots of people who tend to be quite selfish and to do good things for themselves and not so much for others, presumably they do that because they want to make themselves happy. Presumably people who do nice things towards others to some degree do that because they want to make the other person happy, in part perhaps because of social image and self-image concerns. But one important hypothesis that Epley and others raise is the question of like, well, are we underestimating how good it might not only make others feel, but also ourselves feel from being nice? That is to say, perhaps one easy way of making ourselves happy is not just by being selfish and maximizing whatever outcomes we get, but really being nice towards others, in part perhaps because it just makes us happy to see when others are happy. Perhaps it makes us happy because others will be then nicer to us. And there's a question about, can we make others and ourselves happier by being more prosocial, perhaps because we underestimate to start with what these effects might be. I don't think there's that much evidence on this specific question, but I'd love to learn more. And when you think about like your own life, you might want to experiment for a while and seeing like trying to be nicer, trying to engage in random acts of kindness, letters of gratitude, and so on. That might be a nice habit to acquire. And you might see it may or may not make you happier. Surely it will make the other person on the receiving end happier. Okay, so let me sort of summarize what we learned and what we studied on social preferences. So first, others' outcomes and utility matter for people's choices quite a bit. So in various situations, essentially, people are willing to give to others and they're influenced by others in their choices. Now, upon closer look, there's not much evidence of pure altruism. Rarely does it seem that people just do stuff for others just for the sake of others doing well. That is to say, like, if people get the chance of like hiding their not so nice actions, they will often take advantage of that. The motivation there often is instead motivation to give to others or be nice to others, to be prosocial, is often saving face in front of others. This is social image, or themselves, which is self-image. So here, and because of that, situational circumstances matter greatly. Societal norms are really important to consider. So when you think about like incentives or any sort of types of structures in organizations, how might you set incentives, or how might we sort of structure certain groups of people working together? Understanding these norms and circumstances is key for fostering pro-sociality. If you want people to be nice to each other, you have to set it up in a way that it's maybe observable what people do, it's encouraged, there's opportunities for reciprocity and so on. So a lot of the design of society, of like a firm, of a group that you work in, or a team that you work in, really seems to matter. So on the one hand, as I said before, it's a little bit disappointing that there's not much pure altruism. But on the other hand, if we sort of understand the motivations for people to engage in acts that are good for others, we can sort of design incentives and structures that people work in accordingly, which will then create people being friendly and cooperative to each other. Second, I showed you that social preferences matter at workplaces. Relative pay can depress incentives to work. This is the evidence by Bandiera, the fruit pickers that I showed you. Pay inequality can lower performance via reduced morale. So like in particular, if pay inequality is seemingly unjustified, that's really bad for worker morale and might lower worker outputs and sort of attendance and so on. Third, social preferences appear to be malleable and shaped by external factors. In particular, there's evidence in favor of the contact hypothesis. Being exposed to others from different backgrounds really seems to make us more tolerant and more understanding, more pro-social towards these other groups, but also more pro-social perhaps in general, which is the evidence by Gautam Rao. And then finally, there's some evidence that biased beliefs may lower prosociality in the sense that like people might invest potentially in how nice they are to others, perhaps because they misunderstand what the effect of engaging in such prosocial act might have on others. And so potentially correcting these beliefs or experimenting might sort of increase prosociality, at least in some settings. Now, what's coming next? What are the next lectures? Lecture number 14 is about limited attention. 15 is about projection and attribution bias. This is the idea that people have trouble projecting how they might feel in different states of the world. That is the idea, if you're really hungry, it's really hard to project how you might feel when you're not hungry and vice versa. We're going to look at that. In lecture 16 and 17, we'll look more specifically about beliefs and learning. We talked a little bit about beliefs already in various ways, but now we're going to talk specifically about like biases in beliefs and learning, as in like people suboptimally learning, perhaps because of computational issues. In a sense, it's really hard to learn in some settings. In part because of motivated beliefs, people might derive utility from their beliefs. As in, for example, I might want to think that I'm a good-looking, smart, and a good teacher. And if I get feedback one way or the other, I might react to positive feedback a lot more. I might sort of update positively if somebody says, Frank, you're really smart. I might sort of update positively because I feel really good about it. If somebody says instead, Frank, you're not so smart, I might mostly ignore that feedback because it might make me feel bad about myself. So that's all for now. Thank you so much.